So I just want to introduce Adam while he's getting set up. This was in the email, and I'll give a little bit that's in here and a little bit more. So Adam's out of San Diego. He's an avid SOTA activator, so he does a lot of SOTA and POTA. He's active with the SoCal SOTA group. I know him and Ron have met a few times, and others may have met him as well. I sent a link to his YouTube channel, so he's recorded a lot of videos about activations. He also has videos on antennas that he's built, so he does a lot of portable antennas. The panels that I gave out tonight are of his design. He both has designed them and used them. One of the things that's not in here, but I think is a really fun thing that I know about Adam that he's kind of humble about, but he's a good guy. So he's a volunteer search and rescue guy down in San Diego. So he goes out, as a volunteer with San Diego sheriffs, other areas down there. If there's like a lost or injured hiker or something like that, he goes out and helps find lost people. He's done this like in the past month or two. I was hearing that he's been out, so he's actively doing that, and he uses radio to help out with that. He's going to tell you about himself. I just want to kind of introduce him, maybe embarrass him a little bit there with some of his resume. But I wanted to let him take it away. So go ahead, Adam. Thank you very much for talking to the club.
Absolutely. Thank you, Matt. Appreciate you guys having me here. So a little bit of a background about me. Matt covered some good elements of it there, but I'm a mechanical and quality engineer by day, but I really don't get to do much engineering in my day job anymore. So ham radio is really a big outlet for me on the design and engineering side of things. As Matt mentioned, I also have a YouTube channel. I haven't posted much there lately, but there's a bunch of good, fun adventure videos there, as well as some projects and things like that I've worked on. And in my remaining free time, I'm a rock climber, a backpacker, and a SAR member as well, and really just a non-stop tinkerer. I like building, tinkering, and experimenting with things. And that's mostly what this presentation is about, what I call the quest for miniaturization, the art of minimalism in portable equipment design. How many of you in the audience do some portable operating? All right, I see a few hands coming up. How about kit building? Any kit builders there? Cool. Anybody do 3D printing? All right, we've got one in there. Maybe we can entice a few more tonight. How about circuit or PCB design? Anybody tinker with that? Yeah, a couple there, good. And then antenna design and construction in general. How many of you have built your own antennas? Awesome, very cool. So those are all different elements of some of the stuff we're gonna look at tonight, and there are very much different degrees of minimalism that I sometimes embark on in my experiments and builds. They range from being at the extreme end of things, which is on the left-hand side of the screen there, your typical 15 amp Anderson power poles, and right next to it there is what I call a micro pixie, or a choking hazard transceiver, which is a functioning 40-meter CW transceiver. It's basically a pixie design that's just downsized to surface mount components and a board that's really, the whole assembly is smaller than a set of Anderson power poles. And that's really toward the extreme end of things. It's not a very functional radio. It doesn't perform well, but sometimes you just do things because you can. And then there's the practical side of minimalism, where you'll take some design features or aspects of a design that you want to just enhance your operating and make things more fun and easier. And on the right hand side of the screen there, those are images of some of the antenna matching units and balance that I've built right onto BNC connectors. And those are incredibly useful and really make it easy to make a small pocket-sized kit to take out into the field. About 10 years ago or so, I was a budding SOTA operator. I'd recently earned my general class license, and had an FT817, built a 40-meter off-center fed dipole, and had 30 feet of RG174 coax, a microphone, and a 4 amp hour lithium battery in a little plastic case that I thought was, the pinnacle of minimalism, and a really small package that weighed in at about 5 pounds. And little did I know that we can really get gear a lot smaller than that, especially with CW. But one thing that kind of kicked off some of this design adventure was looking for a small packable antenna that I wouldn't have to carry 30 feet of coax to take out into the field. And I came across an antenna made by Par end feds at the time. They're trail friendly 10, 20, 40 meter, 10, 20 and 40 meter end fed half wave. And that allowed me to use a very short piece of coax to connect that antenna to the rig and be able to operate with a little bit smaller package there. And I thought at the time, there's no way I could ever come up with a smaller design than that antenna, with its injection molded case for the matching unit and the 26 gauge wire. But one day on the workbench at home, I had some antenna and coax BNC connector parts laying around, and I took an FT50 size toroid and set it down on top of a BNC connector, and I thought, I'll bet I could build a 49-to-1 unun directly onto this BNC connector. So I got the Dremel tool out, took off part of the BNC case there, soldered in a small 100 picofarad capacitor in shunt across the input, wound a toroid, very carefully soldered the ends of the magnet wire into place, and built the first of these tiny matching units. And I posted a video of this, and many people tried to build it, but it was a little bit difficult, right? These are very small parts, and you need really some precision operating to be able to build this. So a friend of mine, Matt, N7MCB, came up with this PCB concept, an easier way to build this matching unit, which he shared with me and offered me to kind of take and run with. And that evolved into the PCB that's on the right side of the screen there, that I now sell and distribute in antenna kits. And these new boards have pads to build the matching unit in a variety of ways, as a 49-to-1 for an end-fed half wave, 9-to-1, 4-to-1, or a 1-to-1 for the center of a dipole. And the PCB makes the construction a bit easier and makes a very packable small antenna that I often just connect directly to the radio without any coax and use myself or the capacitive coupling to the ground as the counterpoise for the end-fed half-wave antenna. And I find it works quite well. So you might notice the winder in this image is a 3D printed winder. And when I first started operating portable, I was buying these injection molded kite winders to wind up my wire and contain things while I had stuff packed up to take out into the field. The winder in the bottom right portion of the image was just about right for a 40-meter end-fed half-wave and 26 gauge wire. The one on the upper left was better for either larger antennas or larger wire, and the company that was selling these ended up discontinuing the smaller one, and that was an impetus for me to take the plunge and go ahead and buy a 3D printer. That way I could design and build my own antenna winders. This was the first iteration of the winders that I came up with, and they evolved over time. This one was specifically designed to fit in a case with a KX2, Elecraft KX2. So I wanted it to be sized nicely to fit into the case, and having that flexibility of being able to make my own design and print different sizes and scales and iterations was just a huge advantage in being able to tailor this equipment for my needs. In this case, on this model, I built a small clip to hold the BNC connector with the matching unit built onto it there. And as time went by, the shape and style of the winders that I was designing also evolved, because I discovered that there were kind of some key features about the shape of the winder that affected how well it performed for me. I started with the ones that I showed you previously, and then I evolved to the wireframe one in the bottom left. And then the subsequent models followed the design that's up at the top wireframe and the bottom right. And what I found was that the shape of those legs that I would wrap the wire around on the winder had a big impact on how easy the wire was to deploy, and also how flat or compactly the wire sat on the winder. And you can see with this shape of winder with the steeper, sharper legs, the wire at the center tends to bulge out a little bit, and when unwinding the wire to set up the antenna, it just didn't really flow off of the ends of the winder as easily as I liked. So I tried a little bit different design, and you can see how much better the wire sits on this winder. It stays straight rather than bulging out across the middle section of the winder. And with the angle, the straight angle of the legs on the end, the wire just slides right off, and it makes for a very quick, easy setup of that antenna. And there's a look again side by side of the first designs and the evolution to the final design of the winder that I now use. So 3D printing opened up a really big world of a bunch of other options as well. Although I, at this point, primarily operate CW when I'm out in the field, I do operate some sideband, but I really don't want to carry this relatively large Elecraft MH3 microphone with me in my tiny portable kit. So I thought, well, what do I actually need to make this rig function? Yeah, the KX2 does have a built-in microphone in the rig, which works, but it's not as convenient. And it's nice to have something that you can hold in your hand. So I came up with this small design of a 3D printed case, basic Electret microphone element, momentary push button switch, and a 3.5 millimeter headphone jack, which coincidentally I also use on the Morse code paddles that I designed that you guys have the opportunity to take home there tonight. So here's a view of the 3D model of the two parts that just snap together, and the inner workings from an electrical standpoint. Pretty simple, simple design, very easy to construct, and it ends up working fairly well. If you guys are CW operators, and if you've done some portable operating, you may remember this paddle that's on the left-hand side of the screen here. It's made by a company called Palm Radio, which went out of business. The designer and builder of those paddles stopped producing them probably about 10 years ago, maybe 8 years ago. And they're pretty much unobtainium at this point. The ones you find on the used market are very expensive. Often $150 or $200 or more, and but they're really nice. They're small. They retract. The levers press back into the case for protection when it's in storage, but you can't get them. So 3D printers are a solution to so many problems. I embarked on an effort to design basically a similarly functioning paddle, similarly sized, shaped, and functioning paddle to the Palm Pico paddle, but in a way that takes advantage of very simple components, cheap parts, and just your standard 3D printing. So these are the four parts of the paddle taken apart there. There's kind of the key element is near the center there, the levers. And the way I solved the the challenge, the key challenge with a set of 3D printed paddles is how you manage to make an effective hinge for the levers to move very smoothly and easily on. And if you've done any CW operating, you understand that it's really important for those levers to not have a lot of resistance to them, for them to be able to move smoothly and crisply, have a light feel to them, and have a distinctive stop when they close the the momentary switch to key either the DIT or the DA side lever. So the solution that I ended up coming up with was using what we call a compliant mechanism. It's basically just a thin section of plastic near the back end of the lever that provides a hinge for the lever to flex on. And because that hinge is about a half an inch tall, it resists motion in all but basically one axis of rotation fairly well and provides a really good feel for the paddle. In the backside is just a 3.5 mm headphone jack, and the small wires that you may be able to see in there connect to or go through holes that intersect some holes that run crosswise through the lever where M3 sized set screws are placed in to provide an adjustable throw, so you can carefully adjust the throw and the feel of the paddle. It doesn't have spring adjustment because it is just flexing plastic that provides the spring, but they do work quite well, and they provide a nice retractable design with a removable base plate, just like the old Palm Pico, but for about $2 or $3 in parts. It's a pretty awesome little setup that you can really just build one to put in every one of your kits. After designing the Pico paddle imitation and 3D printing that, I decided I wanted a paddle that had a little bit larger levers, was not necessarily retractable, but also had adjustable spring tension. So not only is adjustable throw an important aspect of a Morse code paddle, but also the spring tension or the resistance of the levers. So I came up with this design. This design utilizes some plastic bars as springs. You can see them in the right-hand image here near the center of the paddle, and a second set screw in each lever is used to provide some preload or some tension on that plastic spring to give you adjustable resistance. And again, in this case, I'm using a compliant mechanism with just thin sections of plastic on these levers to allow for flex there. And because the range of motion on these levers is so small in a paddle like this, they really don't wear out. If you drop them onto the levers, they can break at that joint. That is a common failure mode if they receive too much of an impact. But from just normal use, if you protect them well, they'll last a very long time. And then in the left-hand image here, you'll see a leg strap base plate that I created to make it easy to control and hold that paddle during use. Here's a couple of images of the 3D models for the second version of the paddle on the left-hand side of the image, and the Palm Pico imitation paddle on the right-hand side of the image. You might note that the levers on the paddle on the right-hand side of the image are bent outward at 45 degrees from the center axis, and that allows for easier printing. Because I need this whole section to be printed together, I needed a way to print those levers and not have them attached to the base plate there of the paddle. So I printed them, set it up so it would be printed in this orientation, and then before you assemble the paddle, you bend those levers back and forth to soften up the spring a little bit and get the right amount of tension that you want in your version of the paddle. Here's another view of the second version of the paddle with those springs, those little plastic rods that function as springs, and you can probably see the hole where the set screw comes across the paddle lever and provides that preload. And then of course the thinner sections near the back end of the paddle where the levers will flex and use that section as a hinge. And if any of you have seen the KH1 as a little portable transceiver, this gives you an idea of the size of these different paddles. The Palm Pico imitation version in the bottom left, a single lever version of one of the paddles on the upper left there, a straight key on the upper right with a nice larger knob and a magnetic base plate, and then a very small, compact, packable straight key on the bottom right. So I use these paddles almost exclusively now when I'm out in the field. I've got a nicer magnetic return paddle here at home, UR5 CDX paddle, but out in the field, I actually ended up selling my Palm Pico paddle because I like the feel of the paddles that I created better than the Pico. The Pico just had a little bit too much flex in the levers for me, so I decided to get rid of that one. So I've really had a blast designing these 3D printed paddles for different projects, and I showed you one aspect of minimalism in antenna design in those end-fed matching unit kits, but I've also kind of gone to the other extreme in antenna design, and what's shown here is not an antenna I built, but it's something that you'd really want to have on a mountaintop if you could, a 7-element 10-meter Yagi. I mean, why not, right? But who wants to carry that up to a mountaintop? It's just not realistic. This thing probably weighs 50 or 80 pounds and would take hours to assemble, let alone try to get up in the air. So there are some portable options for things like this. There's the Buddy Hex is a portable hex beam that you can purchase from the Buddy Pole company, and hex beam is essentially a set of 2-element Yagis with bent elements that provide pretty darn good front to back ratio and a little bit of gain. And then another commercial option is an antenna called a spider beam, which is shown on the right hand side here, and basically it's a wire Yagi with a center hub section, some roughly 18-foot spreader poles that are used to support all these wires, and then different wire elements for different bands. So in this example here, the blue elements create a 4-element 10-meter Yagi, which is pretty impressive for a portable antenna. So I said, well, I might as well build one of those myself. So I took 4 16-foot telescopic fiberglass poles, welded up a center hub, and created this 4-element 10-meter wire Yagi. Packed it out to a summit, had some fun during a 10-meter contest, but 4 elements just clearly wasn't enough. So I went back to work and started trying to minimize that 7-element Yagi as best I could to make it packable so I could bring it out to a summit. And this is essentially the design that I came up with. It's very heavily based on the spider beam design. So 4 telescopic spreader poles, roughly a 36-foot boom length, and wire elements that are spread out between these pieces. I modeled it up in a piece of software called MMANA. It's like an EasyNeck type antenna modeling software, and this was the radiation pattern that I was able to come up with for a free space radiation pattern. 8 dBd of forward gain in free space is not too shabby. So I got to work designing again in 3D printed material for the center hub, a spot to connect 4 of these 18-foot telescopic poles, and also a center vertical support to help with just the mechanical strength and rigidity of this. And of course, you know, when you've got a directional antenna, you need a rotator with it. So I found a small 12-volt geared motor and some toothed belts and some toothed pulleys that I could use to rotate this hub on top of a mast. And I started building a kit. This is what it packs down to, and these poles I think are roughly, I don't know, 20 to 24 inches in length, so they're relatively small. You can see a couple of my smaller 3D printed winders and a couple of those larger injection molded wire winders that I was showing you previously. And I set it up in the front yard, started testing and tuning and getting this assembled. The mast in this case is just a 12-foot pool cleaning pole, which makes for a relatively lightweight and somewhat packable aluminum mast. And hopefully you can see well enough. There are some low stretch Spectra fishing line, bright yellow or green color guy lines that string all these wires out and provide the structural support for this contraption. And then the black wires in, you know, that cross the center section there along the boom are the passive elements, and then the one driven element kind of toward the rear of the antenna there. So finally I had the opportunity to bring this out to a summit about a year ago in November for what was really the perfect event to try it out. A transatlantic Summits on the Air summit to summit day. So as I'm sure you guys know, working Europe from Southern California is not nearly as easy as working Europe from the rest of the country. So I had my work cut out for me to try to compete with all these other stations throughout the US and trying to make as many European summit to summit contacts as possible. So I brought out this 7-element 10-meter Yagi, and on the right hand side here is a 15-meter Moxon, which is probably a much more practical portable antenna. But between the two of those and an IC 7300 that I backpacked in about 1.5 miles to the summit, I had a wonderful night of operating. This was my contact map from about 6 hours total of operating on a Friday evening, working across the Pacific, and then on a Saturday morning until about 9:30 or 10 a.m. working Europe from the Southern California area. 170 total QSOs, 113 of which were DX. I worked 26 different DX entities, including 87 Europeans contacts and 18 European summit to summit contacts, which was pretty amazing because some of those stations are just running, you know, 5 watts and a little compromise antenna. Some of the comments from some of the other operators in the event were G8AAD. For me, the standout US station was K6ARK, who was a good couple of S units stronger than any other activator and on par with the In the Shack Americans. And this was, you know, working from Southern California. And then the longest summit to summit with one of the stations was with me, which was pretty cool. So quite an amazing event that was. And I did shoot video of that event. I haven't finished editing it, but I do have a short clip here that I can share. So if the audio starts coming through, give me a thumbs up to let me know you're hearing it. Getting a little rocky here. It is beautiful out here. It's a very heavy pack. I had about 55 pounds of gear.
We are getting close.
Overnight
That's
stuff.
The summit right up there.
Batteries.
Mine
IC
benchmark
7300 antenna.
with incredible views. All right, I got to figure out where I'm going to get set up here. I only have maybe 45 minutes of direct sun left. Looks like a good spot right over there. So I think we'll do that. I think we need to take a look at what kind of ridiculousness is in and on this pack. 2 masts, my pool cleaning pole mast and Gigadude 25 with the rotator. 5 telescopic poles. A pile of coax. 4 more telescopic poles, a hub, some wire, and parts for a 15-meter Moxon. IC 7300. Another 6 or 8 amp hours of battery. Antenna switch. 12 amp hour bioenno. I gotta get some antenna set up because that sun's going down pretty quick.
So the construction process for that big antenna takes 30 to 40 minutes, you know, if I'm really working at it. So it's not a fast proposition.
Well, I know you may not have gotten the best feel for how this thing is built, but there you have it, in the air, 7-element, 10-meter Yagi on a remote SOTA summit. This is so cool.
Victor Kilo 6 Radio Charlie.
Victor Kilo 6 Radio Charlie VK6RC 5757 QSL.
Yeah, QSL, thanks for the 5-7. Good evening to you. You're 5 and 353, and all noted you're working a summit. So 53, very good signal. Kilo 6 Alpha Radio Charlie. Name is Marty Mike Alpha Radio Tango Yankee QDH Perth on the west coast of Australia. VK6 Radio Charlie.
Roger, Roger. Thank you, Marty. Correction on the call. Kilo 6 Alpha Romeo Kilo. Kilo 6 Alpha Romeo Kilo. Appreciate you coming back to the call from Perth on single sideband this evening. 7-element Yagi here, 7-element wire Yagi that weighs about 10 pounds, and I can pack it up to a summit. Over.
Yeah, QSL Kilo 6 Alpha Radio Kilo. Yankee Bravo 2 November Delta X-ray QRP. Yankee Bravo 2 November Delta X-ray QRP.
Yankee Bravo 2 November Delta X-ray QRP. Thank you. You're 55 into Southern California this evening. I'm running 40 watts and a 7-element wire Yagi. Back to you.
Yes, listen, Kilo 6 Alpha Romeo Kilo. You are 5859. I received you 5859 Central Java. My name is Eric, Echo Radio India Charlie Kilo. Eric is my name. At this moment I'm running on the 5 watt. Kilo 6 Alpha Radio Kilo, Yankee Bravo 2 November Delta X-ray QRP. Over.
So you can see it was a pretty solid success, being able to work even a QRP station in Indonesia. The bands were certainly in decent condition, which helped, but the antenna really performed quite well for me. I was pretty happy about it. Let's see here. So my challenge to you is to do some of your own experimentation and design and construction. I've had a lot of failures along the way with this stuff. You might have seen even just in that video with the giant 7-element Yagi, how it was sort of blowing in the wind and wasn't particularly stable up there. It's certainly a fair weather antenna, and it has its strengths and its weaknesses. And I've had other antenna designs that simply just didn't work and had to sort out a lot of problems on the way. But that's really part of the fun, and you learn so much doing it. And in the end, you can come up with some really cool stuff that can support your operations, whether it's at home or in the field, or for, you know, emergency service support. Whatever your part of the hobby is, I really encourage you to think about how you can come up with some new designs or innovations that can help you be more effective and have more fun in that process. So, so I'll throw it back to Matt and see if anybody has any questions or anything you guys would like me to talk a little bit more about.
The mic is on, so he can hear you guys. Anyone's had a question?
I do have one question. First of all, thanks so much for your video. I see your True SDX, the part that comes apart that allows you to put different RF boards for different bands. That's a great project. So that was really cool. What tools do you use for your solid modeling?
Yeah, so I use Fusion 360, and I'll bring up so a couple things here to expound on what you mentioned. This is my website, K6ARK.com. Pretty easy to remember with just the call sign there. And through this, you can link to my antenna kits on Amazon, which are pretty much all sold out right now because kits are a side hobby for me and not my day job. But they are occasionally in stock, so you can find those links there. But really the other thing you can find here are some links to 3D prints and PCBs. This is a link to my printables page. And if you open that up, you'll see all these different 3D printed models that or 3D models that I've designed. And the one that you mentioned is this guy here. It's a True SDX modular case. And the True SDX is a really cool little kind of minimalist SDR that takes some really cheap and simple components, an Arduino processor, and creates a 5-band transceiver that can operate on digital CW and sideband, which is pretty amazing for about $100 in parts. And I modified the case design so you can snap in and out a different RF and filter board on the bottom half of the unit and change the set of bands that you're able to operate on. So yeah, I use Fusion 360 for design. For PCB design in the past, I've used Autodesk Eagle, and Eagle is getting phased out and rolled into Fusion 360, which is quite convenient. So yeah, that's my tool of choice, and it has both a free version for hobbyists and a paid version. Since I sell some of the stuff that I design, I pay for Fusion 360, and it's a little pricey, but they have a really good product, and I'm happy to support Autodesk in making that.
This site, printable, so all of the designs that he's showing you here, you don't have to pay to download these. So Adam's giving these away. The paddle that I gave out tonight he showed it in the PowerPoint. It's also one of the paddles. Yeah, that's the paddle right there so I just downloaded the STLs from printables, printed a whole bunch of them using the right material. He's got links in here for usually Amazon links for the different components that you need, like the TRS jack or whatever, the set screws, all of that stuff. So that's exactly what I just went through here. I didn't reach out to Adam or anything. I just went on the site and did this. I have a few of the Pico paddles printed but not built yet because I really want a set of those. But this stuff is all like freely available. If you have a 3D printer, you can go to this site, download the STLs, and print these.
That's right. Yeah, I don't sell any of these. I did sell some built ones initially when I first came up with the design for both the Pico and the other paddle. But at this point, I just share the designs and encourage people to build for themselves and for others. My licensing on these does not allow for commercial sales, so you can't build these and sell them for profit. But because my goal is to get people to build them themselves and just share and be good hams and encourage people to propagate this stuff through the hobby. So.
Any other questions?
Yeah.
Okay.
What new exciting things do you have on the workbench, Adam?
Good question. So let's see here. Let me bring up. I built a QMX, the QRP Labs little transceiver, and I designed some knobs for that recently. But what I most recently built for that was the QMX amplifier, QCX amplifier. It's a small amplifier that comes as a kit and can be used with the QMX or QCX. But the drawback to it is that it's only got one filter inside, one low pass filter. So I thought, well, how can I easily make this multi-banded? Can I cram multiple filters inside? And I decided, the easiest solution is probably to just build some external low pass filters and build the internal filter for the highest band of operation that I want to use. Because if I build a 10-meter low pass filter, it doesn't matter if I'm on 15, 20, 30, 40, 80, all that stuff's going to make it right through that 10-meter low pass filter. I just need to add another filter to knock down those spurious emissions, those harmonics on those other bands. So what I discovered was that this amp actually doesn't work great on 10 meters. It kind of maxes out at about 15 from an efficiency and gain perspective. But regardless, I built the internal filter for 10 meters. And then I designed some PCBs for a very simple low pass filter based on a GQRP schematic and design. But I used the same BNC connectors that I have hundreds of for my kits, but soldered them onto made some pads and soldered them onto the ends of the boards instead of as through-hole components. And then I designed and 3D printed some covers for the filters. So what I ended up with are these nice small oh, that's the battery build that I did for it. But ended up with some nice small filters in a little 3D printed tray that gives me exactly what I need to operate on all the bands I want with a very small kit. So that's been probably one of the kind of primary projects that I've been putting some effort into lately.
Have you put it on a scope yet to see are the filters working effectively and killing the spurs?
They absolutely are, yeah. And what I actually discovered was that I don't need all these filters for different bands. The 15-meter filter sufficiently knocks down the harmonics on 17 meters as well. And I haven't tested it yet, but I think the 20-meter filter may be sufficient for 30 meters because of the angle of the slope and how much it kills the harmonics to meet the minus 43 dB requirement for FCC. So yeah, that makes it a nice, relatively compact kit. The whole package here with my 5S2P 18650 battery pack, so 21 volts in. What is that, about a 5 or 6 amp hour 21 volt pack? The QMX itself, the amp and 3 filters and a paddle weighs right about 3 pounds. If I add a 40-meter end-fed half wave, it's like 3 1/4 or 3.5 pounds. So there's a few images of the battery pack build there, which is a lot of fun to tinker with as well, build your own battery packs.
What do you weld the packs with?
I use a Chinese-made battery spot welder. It's a capacitor-based one. I can't think of the name or model off the top of my head, but it has some very large capacitors in it that handle, I think maintain up to about 5 volts or so, but can discharge a very high current in a small amount of time, and it has a a mode that's either automated or a foot pedal switch activated. And I want to say I spent about $200 on it, and it works very well. It's a solid option. I've used some of the others as well that are just lithium battery based and rechargeable, and they're a little bit hit or miss. They can be effective, and you can find them for probably 40 or 50 bucks, but the performance isn't quite the same.
What's your average pack weight when you're going out on SOTA?
So it varies a lot. Let's see. So the one with the 10-meter Yagi was obviously at the extreme upper end, right? It was probably 55 pounds with, overnight gear, 20 amp hours of battery, 2 directional antennas, 2 masts, an IC7300. So that was an extreme, but for trips like the Sierra Solitude ones, that was like a 2 or 3 night trip in the Sierra to go to a peak that's about 20 miles into the backcountry. And I packed a 20-liter pack that I want to say was about 18 or 20 pounds for 3 or 4 nights like that. So I can keep the pack weight down pretty good. This was another kind of fun example. This was a challenge that Josh K6ARK put together called the 1 pound POTA pack challenge, and I was able to get my kit down to 6.5 ounces for for a transceiver that I could operate on digital CW and single sideband. Not a high performing kit, but functional nonetheless. So for example, the antenna that I was using for that, let's see if I have I might have photos of that. The antenna that I was using for that used an FT, I think 37-43 toroid, or 32, I forget what size it is, on an SMA connector and 36 gauge wire. So it was there it is, 1 pound POTA challenge. So that was this antenna here. And if you know this, that's an SMA connector, so you get an idea for the the size of the wire that's involved there. A 300 milliamp hour lithium battery pack, a little digital adapter for my phone that I created. That's another one of the circuit projects. So yeah, that's that's at the extreme lightweight end. The another setup that I often use for SOTA when I'm concerned about weight is a Mountain Topper MTR2B, a 2-band version of the Mountain Topper with these components in it. It's a custom 3D printed case, which cut the whole weight of the rig by about 50 or 60%. A small 9-volt form factor rechargeable battery, earbuds, and 28 or 30 gauge wire with a matching unit built onto an RCA connector, which is what this radio uses. And the Morse code paddle for this is a capacitive touch key that uses these brass touch points on the corner of the radio, just like the new Mountain Topper that's coming out.
Are they giving you royalties for taking that design element from you?
No. I did ask that they give me credit, because I in mention on their page, because I did send them some of these PCBs that I designed to tinker with, and gave them some feedback in there about a year ago when they were designing it. So
what was your most exciting summit?
Oh, that's a tough one. I mean, there's a bunch of different ones that are exciting for different reasons. And I would say just from a sheer operating and operating enjoyment or contact perspective, the operating with that 7-element 10-meter Yagi and making all those DX contacts was pretty amazing. That was an incredible day.
Well, thank you very much, Adam. This was a really, really great talk. So I appreciate you taking the time out of your very, very busy schedule to chat with the club. Hopefully you'll be willing to do this again for us sometime. But this was really wonderful. So thank you very much.
Absolutely. Yeah, I'd be happy to. I do host a local net on a repeater here nearby and periodically do some little presentations there as well. So I've got some of those that I could show again, talking about propagation and different, some kind of technical topics that are kind of interesting. And then also other projects and things like the micropixie and stuff like that are fun as well. So I'd be happy to do it.
Thank you.
I have one question I'd like to ask you.
Sure.
How old are you?
I am 44.
See
So
there, a young person that we're
Yep.
trying to get into ham radio.
yeah,
That's young, yes.
yeah.
Thank
Yeah, and I think it's really important to try to get people of all ages into radio. I hear a lot of people focusing on trying to get kids into radio, and I think that's really a challenge. I think we need to make it visible and show the value and where it overlaps with other STEM and other fun hobbies they may be interested in. Make it available, but I think where you really hook people is people that have jobs and some disposable income and are looking for a hobby and some fun things to tinker with and learn. And that's what brought me into it, wanting to learn more about it for search and rescue function, because we were using handheld radios for that, and I just wanted to understand them better, and started playing with them and got the technician class license, and then picked up a 10-meter Radio Shack HTX10, made my first 10-meter sideband contact to a guy in Chicago who happened to be just an incredibly friendly and helpful person, and really set that that hook and got me going full bore on it. So
very interesting.
Thank you.
yeah, thank you all. Appreciate you having me.
It's